Okay, number 12 says to find the vertex form of the function, then find each of the following. Okay, so for number 12, our function s of x is equal to x squared minus 8x plus 15. Okay, and so here we want to find the vertex form first, and then part A will find the intercepts, part B will find the vertex, part C the maximum or the minimum, and D the range. Okay, so the first thing I want to do is put this in vertex form. And so vertex form will be s of x equal to a times the x minus h squared to the quantity x minus h squared plus k. Okay, in this case, my hk represents my vertex. Okay, so if I have minus h, then I'll have a positive h. And for k, k is exactly what I see here. K. Okay, so we'll take the standard form and convert it to vertex form. We have s of x equal x squared minus 8x. And I'll leave a space here so we can complete the square and then keep our plus 15. Sorry. So in order to complete the square, we'll add b half squared okay, let's do b halves that way squared. Okay, so if I look at my equation or my function here, b is a negative 8. So if I add b half squared, I'll add a negative 8 halves squared. And if I add a negative 8 halves squared, I want to come over here and subtract a negative 8 halves squared. Okay, and that will keep our function equivalent. Okay, so we have s of x is equal to x squared minus 8x. Negative 8 halves is a negative 4. Negative 4 squared is 16. So I'll add 16. Okay. And so here I have plus 15, and then I'll subtract 16. Okay. So we added our b half squared, but we're keeping our function equal by subtracting that number. Okay. So here we've completed the square. And so s of x is equal to x squared minus 8x plus 16 is a factor of x minus 4 squared. So we have x minus 4 times x minus 4. And then here 15 minus 16 is a negative 1. Okay. And so here we have it in vertex form. Now we have x minus h, which is 4, quantity squared, minus 1, which is our k. Okay, so that's our vertex form. Okay, part A says to find the intercepts. Okay, and so by intercepts, we mean both the x-intercepts and the y-intercept. Okay, the x-intercepts are found by setting the function f of x equals 0. And the y-intercept is found by evaluating the function at 0. Okay, so if you remember from before, the x-intercepts will be where y equals 0, and the y-intercepts will be where x equals 0. But in this case, we'll just plug in 0 to the function, so we'll evaluate for 0 of x. And here, f of x and y are the same thing. So when we find f of x equals 0, we're actually finding y equal to 0. Okay, let's look at the y-intercept first. Okay, so for our y-intercept, we'll evaluate our function for 0. And so our function was given s of x equals x squared minus 8x plus 15. Okay. You can use this function to evaluate, or you can use the vertex form x minus 4 quantity squared minus 1. Okay, I'm going to use the standard form. So we have s of 0 equals 0 squared minus 8 times 0 plus 15. And so the y-intercept, if we evaluate the function for 0, it will always be, when it's a quadratic, the constant. Okay, so our y-intercept is 15. Okay, or you can express the point. I plugged in 0 for x and I got a 15 for y, so it'll be the point 0, 15. Okay, for the x-intercepts, we know we'll set the function f of x equals to 0. So in this case here, s of x, our function, x squared minus 8x plus 15 equals 0. You can solve this by factoring, or you can solve this by using the quadratic formula. Okay, here I'll factor. This will be quicker. So x squared is x times x. 2 factors of 15 that will add up or subtract to give you negative 8 will be 5 times 3 is 15. To get a negative 8, I need to take the difference of both. Okay, so we have x minus 5 equals 0. And x minus 3 equals 0. If I have the product of 2 and they both equal 0, I can use a zero product property to solve. Okay, so here I'll add 5 on both sides to solve for x. So I get one intercept of 5. For x minus 3, I'll add 3 on both sides to get x equals 3. Okay, so my two x-intercepts are 3 and 5. Okay, or if I want to express those in terms of a point, if I know if I know y is 0, then here my first point will be 3, 0, and then here 5, 0. Okay, so in this case here, it just asks for what the intercepts are, so we'll just give 3 and 5 and just separate them with the comma. So those are our x-intercepts, and for the y-intercept we'll just give 15. Okay, let's look at part B. Okay, for part B we're asked to find the vertex. Okay, so from the vertex form that we found earlier, we had s of x equals x minus 4 quantity squared minus 1. Okay, and so we know our vertex is just going to be hk. So here's our h, which is 4, and our k, which is negative 1. So our vertex is 4, negative 1. Remember, if it's a minus 4, it's opposite. It'll be positive 4. But for k, it'll be exactly what you see there. Okay. Okay, now, another way to find the vertex form, if you keep the standard form, or the general form, I say standard form, it's the general form, s of x equals x squared minus 8x plus 15. Another way of finding the vertex is to use negative b over 2a to find the x coordinate, and then you'll take that value and plug it into the original function f of negative b over 2a. Okay, and so here I know a is equal to 1, b is equal to negative 8. Okay, so to find my vertex, I'll first find a negative b over 2a. Negative b is negative 8, so I'll plug in a negative 8 over 2 times a is 1. So the opposite of a negative 8 is a positive 8 over 2 times 1 is 2. And so our x coordinate is 4. Okay, and then I'll evaluate my function for f of negative b over 2a. So in this case, we'll evaluate the function for 4. And so I'll plug in 4 into the function here. So I have 4 squared minus 8 times 4 plus 15. And so in this case here, 4 squared is 16 minus 8 times 4 is a negative 32 plus 15. And so 16 minus 32 is a negative 16 plus 15. And so here I'll have a negative 1. So that gives me my y-coordinate of my vertex, a negative 1. Okay, so you can use either method to find the vertex of the function. Okay. For part C, it asks, does the function have a maximum or a minimum? Okay, so the way you determine if your function has a maximum or a minimum, you first look at what A is. Okay, so what is A? So in either form, let's do this in green. Either form, our A is 1 or 1 here. Okay, and so if A is positive, if A is greater than 0 or positive, our vertex opens upward. If A is less than 0 or negative, our vertex opens downward. Okay, in this case here, A is equal to a positive 1, so our vertex will open upward, which means we'll have a minimum value. Okay, and so I know my vertex was given as 4, negative 1. The y-coordinate will always be the maximum or the minimum value, but in this case here we'll have a minimum. Okay, so we'll say here for part C, does the function have a maximum or a minimum? It has a minimum. Okay, then it asks the maximum or the minimum value is, in this case it would be negative 1. Okay. Part D asks for the range of the function. Okay, so let's look at that one. Okay, so for the function, we know our vertex is, let's see, 4, negative 1. So we have 1, 2, 3, 4 to the right on the x-axis, and then negative 1 on the y-axis. And we'll graph this in blue. So we have negative 4. I'm sorry, positive 4, negative 1. We have our intercepts of 3, 1, 2, 3, and 5, 4, 5. Okay, and we know our parabola opens upward because we have a positive value for A. Okay, so our range will be all of the possible values of the function, all of the possible y values of the function. Okay. And so in this case here, if we look at the y-axis or reflection of the graph toward the y-axis, we see that it starts at negative 1. Okay. And then both ends go to infinity. So here it goes to infinity. Okay. So our range is negative 1 to positive infinity with negative 1 included. And so this is just going to represent all of my values greater than or equal to negative 1. Okay, so this is the interval notation. Okay, and here they just want the inequality that represents the range. Okay, so you'll give y greater than or equal to negative 1. Okay, let's look at number 13. Okay, so 13 says to find the domain of the function f of x is equal to 2x cubed plus 9x squared. Okay, so notice here the degree of this polynomial is 3. Any degree of 2 or higher has a domain of negative to positive infinity. So all of the possible values of x for this function will be all real numbers from negative infinity to positive infinity. Okay, so here we'll choose C. Okay, for 14, it says to find the domain of the following function. And so here we have a rational function f of x equals x minus 6 divided by x plus 9. Okay, where x plus 9 cannot equal 0. In this case, we can't get a 0 denominator, or it will give us an undefined function. So here we say x plus 9 cannot be 0. Okay, so the domain for this function is all real numbers except for the value of x that causes us to have a 0 denominator. Okay, So to find the domain of this, we'll say x plus 9 equals 0, and we'll subtract 9 on both sides of the equation. When x equals negative 9, our function is undefined. Okay? So here, let's put when x equals negative 9, f of x is undefined. Okay? So our domain for this function will be all real numbers except for negative 9. Okay? So let's see. We'll say the set of all real numbers except for x equals negative 9, part B. Okay, and the way you'd express that in interval notation, all real numbers except for negative 9. So you do a parentheses here. Okay, and you give a domain of negative infinity to negative 9, union negative 9 to infinity. Okay, or set builder notation, the set of all x such that x just does not equal negative 9. Okay, let's look at 15. Okay, 15 asks to find the domain of the function g of x. And so g of x is given as the square root of 6 minus x. Okay, so when we have the square root or any even root, a square root, a fourth root, a sixth root, we want to exclude any value for the expression here that causes our expression to be negative. Okay, so we want to exclude any negative values for this expression. And so what we do is we just take the expression 6 minus x and make sure it's a positive or 0. And so we say that that expression 6 minus x has to be greater than or equal to 0. That way we don't get the square root of a negative, and it could be square root of any negative number, giving us an imaginary number. Okay, and so here if we subtract 6 on both sides, we get a negative x is greater than or equal to negative 6. If we divide by negative 1 or multiply by negative 1, it doesn't matter here. We'll flip the direction of the inequality, and so x has to be less than or equal to 6. Okay, so as long as x is less than or equal to 6, we will not have to take the square root of a negative. So that's our domain for the square root of 6 minus x. Okay, and so in this case here, I'll graph it. 6 less than or equal to 6 is everything left of 6 with a square bracket here because it says it can also equal 6. And so our domain will be starting from the left endpoint, negative infinity to 6. Okay. Okay, let's look at number 16. Okay, number 16 says to find the value of $15,000 at the end of 1 year if it is invested in an account that has an interest rate of 4.5% and is compounded in accordance with the rules below. Okay, so part A says that it's compounded monthly, part B compounded daily, and part C compounded quarterly. So each of these represent the formula for n compoundings per year. So we have the accumulated value, or the future value, A, is equal to the principal, P, times 1 plus the rate, R, over the number of compoundings, N, raised to the number of compoundings, N, times the time, T, in years. Okay, so if we look at problem 16, it says here that we're finding a value of 15,000. And so this represents our P at the end of 1 year. So our time is 1. Invested in an account that has an interest rate of 4.5%. So our rate is 4.5%. But we'll express the rate as 0.045. Moving the decimal to the left twice. Okay, and then we'll determine our N for each part. Okay, so for part A, it says that it's compounded monthly. There are 12 months in a year, so N is equal to 12. Okay, so let's find part A. Our accumulated value, or our future value, will be equal to P, which is 15,000, times 1 plus the rate, 0.045, divided by the number of compoundings, 12, raised to 12 times the years, or the years given as 1. Okay, so our future value is approximately $15,689.10. Okay, so if you're not getting this value, make sure when you type everything in, you're putting the 12 times 1 in parentheses, and then make sure you have your parentheses here. Okay, and so to raise this, you choose the caret button to raise it to that power. Okay, let's look at part B. Okay, B says that the interest is compounded daily. Okay, so here if we have compounded daily, there's 365 days in a year, so N will be 365. Okay, so our future value, or our accumulated value, A, is equal to 15,000 times 1 plus 0.045 divided by N, which will be 365, raised to the 365 times 1. Okay, so here A is approximately $15,690.37. Okay, let's look at part C. Okay, part C says that it's compounded quarterly. There's 4 quarters in a year, so quarterly will be N equal to 4. So we have our accumulated value of 15,000 times 1 plus 0.045 divided by 4 compoundings per year, raised to the 4 times 1. Okay, so the accumulated value is approximately $15,686.48. Okay, let's look at number 17. Okay, number 17 says to find the value of an investment of $25,000 for 14 years at an annual interest rate of 4.55%, compounded continuously. Okay, so here our compounded continuously formula will be A equals to the principal times E to the RT, which just represents the accumulated value equal to the principal times the natural base E raised to the rate times the time. Okay, and so here for P, it gives us 25,000. 14 years represents our T. Our interest rate, R, is equal to 4.55%, but we'll change it to a decimal to 0.0455. So you can just move the decimal to the left twice, or divide 4.55 by 100. Okay, and so here our accumulated value will be equal to, 15, it's 25,000. Okay, 25,000 times E to the 0.0455 times 14. Okay, and so here, if we type this in, the accumulated value is approximately $47,269.99, or 0.999. So we'll round this to $47,270. Okay. Okay, let's look at number 18. Okay, number 18 says to solve the equation to 4 decimal places. We have here 2.802 raised to the 14t equals 2. Okay, so to solve an exponential equation, we first want to isolate the exponential portion or the exponential expression. In this case, it's already isolated. Okay, so we'll now do the inverse of an exponential, which is a log. So we'll apply a natural log or common log, but in this case, we'll do natural. Natural log of 2.802 raised to the 14t equals, and we'll also apply natural log to the right so that the equation remains equivalent. Okay, once we apply natural log, we can use the power rule and bring down the 14t, the power or the exponent in front, and multiply it to the natural log of 2.802, and that equals to the natural log of 2. Okay, so here we're trying to solve for t, or we want to determine t rounded to 4 decimal places. And so in this case here, 14 is multiplied to t, and the natural log of 2.802 is multiplied to t. So here we'll do the inverse and divide by 14 times the natural log of 2.802. Okay, and then we'll do the same thing on the right side so that it remains equivalent. 2.802. Okay, so on the left, the 4's will cancel, the natural logs will cancel, and we're left with t equals the natural log of 2 divided by 14 times the natural log of 2.802. So when you're typing this in, be careful to put the denominator in parentheses so that you'll get the right value. Okay. Okay, so the natural log of 2 divided by 14 times the natural log of 2.802 comes out to be 0.048059 ... And so if we're rounding, t is approximately rounded to 4 decimal places, 0.0481. Okay, let's look at 19. 19 says, a couple just had a baby. How much should they invest now at 5.6% compounded daily in order to have $40,000 for the child's education 17 years from now? Compute the answer to the nearest dollar. Okay, so let's erase this so we'll have more space. Okay, so here it says compounded daily, so we'll use the n compoundings per year formula. A equals P times 1 plus R over n raised to the nt. Okay, and so here it says how much should the couple invest now. That's the principal. That's what we need to determine. Okay, at 5%, 5.6%. So our rate is 0.056 if we move the decimal to the left twice or divide by 100. Compounded daily. Daily represents 365 days in a year. In order to have $40,000, that's the value you want to accumulate or you want for a future value. Okay. And then into the child's education 17 years from now. So our time is equal to 17. Okay. So our A is given to be 40,000 equal to P, that's what we're trying to determine, times 1 plus the rate 0.056 divided by the number of compoundings 365 raised to n 365 times t 17. Okay, and so here be careful to put that in parentheses if it doesn't do an exponent. Okay, so P is being multiplied to this whole exponential expression, so I could just divide P times 1 plus 0.056 divided by 365 raised to the 365 times 17. I could divide that whole exponential expression. Okay. Okay, and if I do that to the right side, I want to do the same thing to the left. Okay, so on the right side, those expressions will cancel and leave me with P. Okay, and on the left side, we have that P is equal to 40,000 divided by 1 plus 0.056 divided by 365 raised to the 365 times 17. Okay. Now, when you're typing this in, be careful to add an additional parentheses. I don't think you need it here, but we'll just make a good habit of it. And then here, 365 is multiplied to 17. Okay. So here, make sure you put that in parentheses as well. Okay. So we have 40,000 divided by, open parentheses, 1, and we'll do an extra. So 2 open parentheses, 1 plus 0.056 divided by 365, close parentheses, raised to the open parentheses, 365 times 17, close parentheses, and then move it down out of the exponent and close it again. Okay. And so in this case here, we have P approximately, well, let's just put what we have first instead of the approximation. So we have P equal to $15,439.86. Okay, or we'll do 86004. But in this case, it tells us to round to the nearest dollar as needed. And so the nearest dollar will be rounding the 39 to 40. Okay, because 9 will round up to 10, which makes the 30 40. Okay, so P is approximately $15,440. Okay, and that's what the couple will need to invest. Okay, let's look at number 20. Okay, number 20 says, or asks, how many years will it take $7,000 to grow to $10,500 if invested at 6%? A, compounded quarterly, and B, compounded continuously. Okay, so for part A, we're using quarterly. So we have the accumulated value A is equal to P times 1 plus R over N raised to the NT. And then for part B, we have continuously. So we'll use the accumulated value A equals PE to the RT. Okay. But let's just do part B in a second. So let's erase that part. Okay, so here, how many years will it take 7,000 to grow to 10,500? So the 7,000 is P, the 10,500 is the future value or the accumulated value. 6% is our rate, which is 0.06 as a decimal. And part A is compounded quarterly, so N equals 4. Okay, and so we're trying to determine how many years, so we're solving for T. Okay. So our accumulated value, 10,500, equals to the principal 7,000 times 1 plus 0.06 divided by 4 raised to the 4t. Okay, so here we need to solve for t, and t is expressed as an exponent. So the first thing we want to do is isolate the exponential portion first. Okay, and so here, since 7,000 is multiplied to this, we'll divide both sides of the equation by 7,000. So the 7,000s will cancel. And we have 10,500 divided by 7,000. Okay, so we get 1.5 is equal to 1 plus 0.06 divided by 4 raised to the 4t. Okay. If you want to simplify the inside portion, the 1 plus 0.06 divided by 4, you can. Just make sure whenever you get a decimal and an irrational number, you go ahead and leave it as an expression so that you don't round until the very end. Okay. And so I'm going to leave it like this. Here to solve for t, I need to apply natural log on both sides. Plus 0.06 divided by 4. Okay. Which will allow me to bring the 4t down in front and no longer be expressed as an exponent. Okay. So here I can take this 4t and bring it out in front and multiply it. Okay. So we have the natural log of 1.5 equals 4t times the natural log of 1 plus 0.06 divided by 4. Okay. And so here, t is multiplied by 4 and the natural log of 1 plus 0.06 divided by 4. So we can divide everything here multiplied to the t. Okay. And if we do that on the left side, we want to do the same thing on, if we do that on the right, we want to do the same thing on the left. So 4 times the natural log of 1 plus 0.06 divided by 4. Okay. And so here the 4's will cancel, and then the natural log of 1 plus 0.06 divided by 4 will also cancel. Okay. And so we're left with t is equal to this expression. Okay. And so that's the exact value. If we type it in, the natural log of 1.5 divided by, and make sure you close the parentheses for 1.5 and put the denominator in parentheses. So we'll put this 4 times the natural log of that expression in parentheses. So natural log of 1.5 divided by parentheses 4 times the natural log of 1 plus 0.06 divided by 4. And we get 6.808309 and so on. And so here it tells us to round to 2 decimal places is needed. So in this case here, t will be equal to 6.81. Okay, so that'll be part A. Okay. Let's look at part B. Okay, for part B, it says that this is compounded continuously. So we're using the cumulative value A is equal to PE to the RT. Okay, and so here our 7,000 is still P. Our future value or our accumulated value is 10,500. Our rate, 6%, is 0.06. And then compounded continuously, we'll use the formula given here, okay, or shown here. And so here we have 10,500 equals 7,000 e to the 0.06 t. Okay, and so just as before, we want to isolate the exponential portion first. And so here, if we divide both sides by 7,000, okay, on the left side, we'll get 1.5 equals e to the 0.06 t. Okay, so to solve for t, we want to apply natural logs to both sides so we can bring the exponent down in front. And so here, if I apply natural log of 1.5 to both sides, okay, it just so happens the natural log has a base of e, so the natural log base e of e simplifies to the exponential portion. Okay, so in this case here, we have the natural log of 1.5 is equal to 0.06 t. Okay, and so to solve for t, we'll just divide by 0.06. Okay, so t is approximately, we're rounding to 2 decimal places, the natural log of 1.5 divided by 0.06, which gives us 6.75775518. And so if we round to 2 decimal places, we get 6.76. Okay, let's look at number 21. Okay, so 21 says a company manufactures microchips. Use the revenue function R of x equal to x times 72 minus 3x and the cost function C of x equals to 120 plus 15x to answer parts A through E, where x is in millions of chips. Let's underline that. R of x and C of x are also in millions of dollars. Okay. Both functions have the domain of x greater than or equal to 1 and less than or equal to 20. Okay, so for the first part, it asks us to form a profit function P and graph R, C, and P in the same rectangular coordinate system. Okay, so our profit function P is equal to the revenue minus the cost. Okay, and so here we have P of x, the profit function, or profit as a function of x, is equal to R of x minus C of x. And R of x is given here in red as x times 72 minus 3x. So here, let's put that in red, x times 72. I'm going to go ahead and distribute. X times 72 is 72x. And then x times a minus 3x or negative 3x will be minus 3x squared. Okay. Minus our cost function C of x. Okay. C of x is given as 120 plus 15x. So here we have 120 plus 15x. Okay. And so if we take the difference of these two, we'll have our profit function. Okay. So we have 72x minus 3x squared minus 120 minus 15x. Okay. Here we'll simplify this and also put it in descending order. So here let's write the negative 3x squared. Okay. 72x minus 15x gives us 57x. So we have here a positive 57x. And then minus 120. Okay, so this is our profit function. A negative 3x squared plus 57x minus 120. Okay. Okay, next it says to graph R, C, and P in the same rectangular coordinate system. So here you'll go to y equals in the calculator and type under y1. You can type in the revenue function. So R of x, x times 72 minus 3x. Or you can type 72x minus 3x squared, either one. Okay. Under y sub 2, you want to type the cost function. So the cost function is 120 plus 15x. Okay. And then P under y sub 3, or beside y sub 3, which is what we have above, negative 3x squared plus 57x minus 120. Okay. And then you'll graph. So click the graph button to graph all three functions. Okay. Now, when you look at the graphs here, shown here, the x minimum is 0, the x max is 20, the y minimum is 0, the y maximum is 440. So if you change your window settings, you'll have a graph that looks more like the graph shown here. Okay. So here, click the window button and change your x min to 0, your x max to 20, okay, and then the x scale, SCL, here we'll come up to the graph and count the tick marks. So here the tick marks in between 0 and 20 count 1, 2, 3, oops, let's go back, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we divide 20 by 10, then our scale will be 2. Okay. For the Y min, we have 0. The Y max, we have 440. And then the Y scale, we'll count the tick marks here between 0 and 440. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we'll divide 440 by 11. And so we have a scale of 40. Okay? And so now you'll choose graph. So here, here, and then graph. Okay? And you want to find the graph that looks like one of the 4 graphs shown here. Okay? So if you look at the graph, the top line goes up to pretty high up toward 440. And so we know that D is not 1. Okay? And then we'll look at the line. The line intersects the top graph, but it does not intersect with the bottom parabola. And so here we'll cancel that one. And then here we'll cancel this because the line goes in the wrong direction. Okay? So in the case here, C is our graph. Okay? Okay, let's look at part B. Okay, 21B. Part B says to discuss the relationship between the intersection points of the graph of R and C and the x-intercepts of P. Okay, so here we're still looking at C. And so let's draw a dotted line from the intersection of the blue dotted parabola and the pink line down to the profit function. Okay. So here's our intersections, or here are our intersections. We draw a dotted line. We see that the x-intercepts, not the x-intercepts, we'll see that the intersections for R and C are equal to the x-intercepts of the green profit function. Okay, so for part B, we can say that those are equal to. Okay. For part C, it says to find the x-intercepts of P to the nearest 1,000 chips. Find the break-even points to the nearest 1,000 chips. Okay. And then it says the x-intercepts of P occur at x equal. Okay. So let's find the x-intercepts of P. We'll use the profit function. P of x is equal to, what did we put earlier? Negative 3x squared plus 57x minus 120. Okay, so the x-intercepts will just be where y is equal to 0 or the profit function equals 0. Okay, and so here we could try factoring out 3 from each term and then factoring, or we can use the quadratic formula. Okay, okay, here I'll use the quadratic formula. Okay, so we have a is equal to negative 3, B is equal to 57, and C is equal to negative 120. Okay, so x equals a negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, and so we have x equals a negative, b is 57, plus or minus the square root of b squared, 57 squared, minus 4 times a, which is negative 3, times c, which is a negative 120. All divided by 2 times a, 2 times negative 3. Okay, so we can simplify the radical portion. And we have a negative 57 plus or minus the square root of 57 squared minus 4 times negative 3 times negative 120 will give us 1809 or 1809 divided by negative 6. Okay, and so here we have two solutions. We have x equals a negative 57 plus the square root of 1809 divided by negative 6. And then x equals a negative 57 minus the square root of 1809 divided by negative 6. Okay, so let's type these in to get the approximation. Okay, on this one, be careful. Make sure you put the numerator in parentheses so that it will calculate it properly. Okay. Okay, so for the first one, negative 57 plus the square root of 1809 divided by negative 6. Get approximately, and we're rounding to, let's see, 2 decimal places. No, 3 decimal places. Okay, so 2.411. Okay, and for negative 57 minus the square root of 1809 divided by negative 6. Here I get 16.589. Okay. And so the x-intercepts of P occur here at 2.411, comma 16.589. Okay. And it says here, since the break-even point is the point at which the profit equals 0, do the x-intercepts of the profit function indicate the break-even points? Okay, so in this case here, yes. Okay, and so if I were to set my revenue function equal to my cost function, that represents my break-even point. Okay, but here if I take my revenue function and subtract my cost function, meaning I'm subtracting c of x on both sides, that gives me the revenue minus cost function equals 0, in which case is the profit function, and that also equals 0. Okay, and so in this case, that's why we can say yes there. Okay, let's look at part D. Okay, let's look at 21D. So 21D. Okay, it says to refer to the graph drawn from part A. Let's circle C. Does the maximum profit appear to occur at the same output level as the maximum revenue? Okay, so notice here the profit function is given in green, and the revenue function is given in R, the dotted quadratic R function. Okay, and so if we look at the maximum profit and the maximum revenue, here I'm going to draw a dot. That's about the maximum profit and about the maximum revenue. And so we can see here, if we just draw a line through, the maximum profit and the maximum revenue occur at different values of x. Okay, and so for this one, part A would be the answer. No, because the x value of the maximum profit is different than the x value of the maximum revenue. Okay. The next question asks, are the maximum profit and the maximum revenue equal? So here, if we look at the same graph, the maximum profit, which will be green, will occur here at Y, and the maximum revenue will occur somewhere here. So you can tell those Y values are different, okay? And so here we can say no, because the maximum profit occurs at a different Y value than the maximum revenue, so part B. Okay. Okay, part E says to verify your conclusion in part D by finding the output to the nearest 1,000 chips that produce the maximum profit. Find the maximum profit to the nearest 1,000 and compare this to the maximum revenue. Okay, so here we want to find the output that produces the maximum profit. So we'll first look at the profit function, and let me put this as 21E. Okay, so our profit function was, let me look at that. Okay, a negative 3x squared plus 57x minus 120. So when we talk about the maximum, here we know A is negative, so the parabola opens downward. So in order to find my maximum value, I'm basically finding my vertex. Okay, so the simpler way to find the vertex in this case would be to find negative b over 2a, f of negative b over 2a, instead of completing the square. So we'll do that. Okay, so we have negative b over 2a equals a negative, here's a, negative 3, b a positive 57, and so we have a negative 57 divided by 2 times a, negative 3. Goodness, I did it wrong. Okay, there. And so we have a negative 57 divided by negative 6. Okay, and so this simplifies to 19 halves, or 9.5. Okay. And so it says by finding the output to the nearest 1,000 chips that produces the maximum profit. So we know this is the vertex. This is the first coordinate of the vertex. So it'll go with the maximum here. So in order to find the y value, the actual maximum value, we'd have to find f of negative b over 2a, which would equal to f of 9.5. Okay, so I'll plug in 9.5 into each of my x's. Okay, and so I get 3 times, or sorry, negative 3. Negative 3 times 9.5 squared plus 57 times 9.5 minus 120. Okay, and so in that case here we get 150.75. Okay, and this gives us our y coordinate of our vertex. Okay, so we have 9.5 comma 150.75, and this represents our vertex there. Okay, so the maximum profit is always going to be the y coordinate. Since this represents the vertex of the profit function, this will represent the maximum profit. Okay, and then this represents where it occurs, and it occurs when we've produced 9.5 millions of chips. So here, so we'll just plug this value in down here. Okay, so the maximum profit goes here, $150.75 million, which occurs when 9.5 million chips are produced. Okay. Okay, so now we'll find the maximum revenue. Let's circle this in blue. Okay, and so the revenue function is given as x times the quantity 72 minus 3x, which we can use negative 3x squared plus 72x. So I just distribute and then I change the order. So x times 72 is the positive 72x. And then x times the negative 3x is the negative 3x squared. Okay. So we'll do the same thing. We'll find the vertex. We have negative b over 2a is equal to a negative. A is negative 3. And b is 72. So we have a negative 72 divided by 2 times negative 3. And so we have a negative 72 divided by negative 6, which gives us 12. And we'll evaluate f at a negative b of 2a. So we'll have f of 12 is equal to negative 3 times 12 squared plus 72 times 12. Okay. So we have negative 3 times 12 squared plus 72 times 12. And we get 432. Okay. And so in this case here, that gives us our maximum revenue because we always go with the y coordinate for the maximum value, 432. So here, our maximum revenue is $432. Okay. And so now we can refer back to D. It says, or asks, does the maximum profit appear to occur at the same output level as the maximum revenue? And in this case here, the maximum profit occurs at 9.5 million chips, and the maximum revenue occurs at 12 million chips. So in that case, we can see that it is no. And then for the second part, it says, are the maximum profit and the maximum revenue equal? Here we have our maximum profit of 157.75, and we have our maximum revenue at 432. Okay, so we can see that those aren't equal either. Okay, that's the review. You can go in and do the practice test online, and then you'll have 2 chances to take your exam by Friday. Okay.